Okay, so in this video we're going to look at cosine. The previous one we looked at the sine and the sine ratio and what that means, and now we're just going to look at cosine. And it's very interesting that they both say sine, and it's sine and cosine. So the co is like they're working together. The co is for complementary, and later we'll see at what that means. But for now, let's just start off with our triangle again. And like we said, we work in 90-degree triangles or right angles. And let's say this is my theta, that's my reference angle, and this is the point A to B. Okay, we saw in the previous video whenever I think about sine will give me an idea of how much this opposite side, let's just name our triangle, this is my opposite side, this is my adjacent side, so adjacent meaning next to the angle, and this is the longest side, so we call this the hypotenuse side. So we saw that sine is giving me an idea of how much vertical force or vertical distance there is when I travel from here to here. So it gives me that distance, okay? Cosine, you guessed it, gives me an idea of the horizontal distance. So if I said cosine of a certain angle, that would be the adjacent over the hypotenuse. Now if you're thinking like, how am I going to remember it? Don't worry, there is a little SOHCAHTOA trick that we do. But for this video, I just want you to understand that cosine has to do with the horizontal displacement or the run part. So sine had to do with rise, and cosine has to do with run. Okay, so let's just think about this. If I'm throwing something from A to B, the adjacent side, the distance from here to here is telling me how far it ran. But the distance from here to here is telling me how much I rose or rised. So cosine, if I had a cosine of, let's say, 30 degrees, this distance to this distance would fit on the hypotenuse at a certain angle. So let's just think if this angle were to get smaller. Let's take something like, let's make it, again, let's start really simple. We'll start with cosine of 0 degrees. So if I had a cosine of 0 degrees and this was getting, let's say this angle is getting smaller and smaller and smaller to 0, would you agree that it would literally just be a line? And the hypotenuse would eventually, like, let's just think about what the adjacent side is doing. If the angle is getting bigger, the adjacent side would get smaller. And if this angle gets smaller, then the adjacent side gets longer. And eventually when I have 0 degrees, the adjacent side and the hypotenuse side are exactly the same length. And it doesn't matter what it is, we can make up, let's say that's a distance of 10. The adjacent side would be 10 and the hypotenuse would be 10. So remember I said that trig is more to do with angles than triangles. So in this case, I don't see a triangle, but hypothetically speaking, what happened is that the opposite side kind of disappeared with this angle going to 0, and then the two lines, which I would have called the hypotenuse side and the adjacent side, are lying on top of each other, and they are the same length. And what happens what would happen, what's 10 over 10? That's 1. So just to prove I'm not lying to you, if I were to say the cosine of 0 degrees, I hope this works, otherwise I'm teaching you wrong, is 1. Oh, thank goodness that worked. So that's why the cosine of 0 is 1, because if I were to put the adjacent side on the hypotenuse side, they'd be both the same length. So let's take the other extreme. Let's say I'm making this side bigger and bigger and bigger and bigger, and this angle, sorry, not the side, I'm making the angle bigger and bigger and bigger and bigger and bigger, and eventually I'd have a straight line like this, where the opposite side is exactly the same length as the hypotenuse. And what happened to the adjacent side? If I had a 90-degree angle here, it disappeared, right? There's nothing there. So if I had the cosine of 90 degrees, what would the adjacent side be? Well, it would be here, it would be a dot, it would be 0, because it disappeared. It just went smaller and smaller and smaller as this angle went bigger and bigger and bigger and bigger. So the adjacent side would be 0. And the hypotenuse side, we don't care what it can be, 10, 20, 50, 100, doesn't really matter. 0 over anything will give me 0. So let's just see if that's true. The cosine of 90 would be, wait for it, 0, stay 0. Because there's no, if this was a ball being thrown, and the ball is being thrown straight up in the air, there's no horizontal force. It's not running anywhere. It's just rising all the time. So there's no force or no distance in the vertical direction. In the horizontal direction. Sorry. If it's being thrown up, straight up, then there's no movement in the horizontal plane. Okay, so let's just quickly recap from this video and the last. Oh, wait, before we talk about the last video, let's just think if we understand this. If I drew 2 triangles, okay, that pen has decided to not work. Let's say I draw 2 triangles here, and they have certain angles. So both of these have 90-degree angles. I'll call them A and B. And then I say that I work out the cosine of one of them, and the cosine of one of them is like something like 0.2, and the cosine of the other one is something like 0.873. Doesn't really matter. This can be 215. Well, let's make it just not too difficult. Let's make it 0.2 and 0.8. Okay. Let's just think. What does cosine tell me? Cosine tells me how much I'm running, the distance I'm running when I'm throwing at a certain angle. So if I'm thinking about, or how much of this line would actually fit on that line. So if I have a big angle, then this would obviously be a smaller part. If I were to put that on there, you see I cover less. But if it's a smaller angle, then this part would cover a lot more. So if I were to take this line up, let's see where it goes, would be there. That's the distance, and that distance, let's say we were comparing that over the whole distance. And in this case, that probably be around there. Would you agree that this line is covering more of the hypotenuse and this line is covering less of the hypotenuse? Okay, it's definitely not according to scale, but you would know that cosine gives me an idea of how much I'm running or how much I'm moving in the horizontal distance. And in this case, I'm moving a lot in the horizontal distance because that angle is small. So this would be A. And in this case, I'm doing less. Because the angle is getting bigger or the angle is big, I'm moving less in the horizontal plane, B. As a last point to kind of try and explain this, if I was playing basketball and I had a ball, and let's say the hoop is here, and this is it, and I want to throw the ball up there, you would agree that if I was thinking about, I'm going to bring the previous video in here. If I'm thinking about my sine and my cosine values, if I'm standing here and I'm throwing it very much high in the vertical direction, then I would expect a high sine value, close to 1. It'll be very close to 1. But the cosine value, because it's traveling just a little distance in the horizontal plane, the cosine value would be low. But if I was standing very far away, standing like here, and trying to throw the ball there, you would agree that if I'm drawing an angle like this, the vertical displacement in this case is a lot less than the horizontal displacement. So if I looked at this angle, the cosine would be high because I'm traveling a lot in the horizontal plane, but the sine value would be lower because I'm traveling a lot more horizontally than I'm traveling vertically. Again, this is not something you need to know They're not going to ask you in any IGCSE, well, IG exam and say, hey, you're throwing a ball, blah, blah, blah. They might, and then you have the understanding, but you always have your calculator with you. But it's just to have an idea of what does sine mean, what does cosine mean. Sine gives me an idea of how much I'm moving up with an angle, and cosine is how much I'm running. In the next video, we're going to look at the tangent ratio.